Hello, my name is Saim Safdur, and welcome to the Cloud Native FM podcast. 10 years of nodes that learn to swing, of clustered hummed and services wing. GKE held the helm through night and day. Once ops kept vigil our upgrades and time, counting versions like clockwork chimes. Then a manage offering rose, steady and kind, lifting toil from the platform team's mind. No more midnight worry of kernels to chase, no more frantic patches to keep up the pace. Freed to design, to test, to seed, making workload fit the developer's need. So here's to the 10 years of steady gears, of teams unburdened, of quiet cheers to GKE, which held the infrastructure flame and gave back time so we could build up the game. Raise your mugs, let the cluster glow. 10 years behind us, many more in the future show. So, this is an episode of GKE 10th anniversary, and I have a wonderful guest with me, Abdel, who is a developer advocate at Google Cloud.
Oh wow! So I did not expect that very awesome introduction. So thank you so much. Hi, Sam. I'm very happy to be here again.
Abdul, tell us how your KubeCon India, what things you have learned from that conference.
It was amazing. It was my first time in India. I've never been there. I went both to Hyderabad and Bangalore. So I started with Hyderabad for KubeCon India. It was very packed. There was 4,000 people, fully sold events. I think the venue was a little bit too small for the event, but it was really packed. For some reason, my session was very popular. So I had people like queuing in the back of the room, standing, sitting in the front. It was crazy. But it was an amazing experience. The food is amazing. The people are awesome. And then from there, I went to Bangalore, which is slightly more kind of crazy and wild and busy and a lot of people. So Hyderabad, to a large extent, felt a little bit more chill. But overall, it was amazing. Yeah, like KubeCon was great, and India was amazing. I'm very happy. I'm looking forward to go back next year.
Awesome, wonderful. I believe that the videos are out on the YouTube as of we actually recording the episode, so I can link the channel, some of the your session as well, because these have some wonderful information for some of the people who are working on GKE or other clusters all the time. So Abdul, this episode, this conversation is all about GKE. And I think GKE is one of the first managed offering in the cloud. After the 2014 is a year when Kubernetes announces as an open source project. I think it's just a matter of the time. GKE was the first to develop and telling people, oh, you don't need to do anything. It's just a managed offering available for you. So tell us how your journey started into the GKE and how long you been in the GKE and how things actually been started.
Yeah. So you're correct in the sense that GKE came a year after Kubernetes release. So Kubernetes was first released 2014, and I think September 2015 was the GKE version 1.0, or at least the first kind of version of it. And it has been evolving quite fast and quite a lot since I started working on GKE in 2018. So three years after it came out, and I've been working on GKE since then. So since 2018, I moved to a team within Google Cloud that basically does consulting. So I was working with customers that are using Google Cloud. And basically, whenever there is a customer or a project where there is a need for a design around Kubernetes and GKE, I would be involved as one of the experts on it. So I remember my first project actually working on GKE was with a large retail store in Sweden, one of the largest retail companies here that does online sales, that were trying to move from on-prem VM-based system to like a containerized kind of Kubernetes-based thing on Google Cloud. And that was the first time I encountered Kubernetes and GKE. And yeah, it's been a wonderful, interesting, wild journey since then. There's a lot of things happening.
Yes, absolutely. And I think one of the very great thing about GK, like every time we know we have a Kubernetes releases 3 times a year. Back then, I believe it's 4 times a year, and some
Oh
people are
yeah.
actually panicking. Oh, please stop this for sprint for us, and let's make that a 3 version. But three, it's still a lot. And if you actually been doing this thing on the manually or on-prem setup, it's been a very challenging task to do.
Is one of the managed offering of Kubernetes that gets new versions the fastest up, like into the into the managed offering. So GKE comes in standards and autopilot mode. And in both standards and autopilot mode, you have this concept of channels. So there is a rapid channel, a stable channel, and a regular channel. So the rapid channel is the channel where if you put your cluster on the rapid channel, we will make new versions of Kubernetes and patch releases available there very quickly. So that's like the channel that gets upgraded the fastest. And that's where you can get the latest version. And so that's actually where we make the last version of Kubernetes available, like roughly 2 weeks after it becomes available upstream. So now we are expecting, I think, Kubernetes 134 to come out somewhere next week. So that's like the last week of August. So somewhere around the first or second week of September, the Rapid channel will have 1.34 available. Now, Rapid doesn't have the same SLA as the other channels. So it is meant for prototyping and, testing and not really meant for production. And then, usually people put, their dev environment in the Rapid channel because they want the clusters to be upgraded very quickly so they can test the applications. And then they would put their QA and prod on either the regular or the stable, usually stable for prod and QA somewhere on the regular channel, right?
The GKE has adopted to the latest release cycle as well. It's one of the fastest one, and that's the great thing about it. And Google is built by the Kubernetes, is built by the Google team, so we can expect things are quite smoothy and quite reflective compared to some other cloud provider in the mix as well. But as I look at the chart, I look at the C on the internet themes, it's a manage and self-managed control plane, autopilot mode, multi-cluster and fleet management, anthems and hybrid multi-cloud, faster upstream support, AI workload readiness, security and hardened by default. So, being on the customer side of the things, Abdul, and also some of the community work you have been doing. So if I ask you, over the years, if I ask you to pick some of the favorite feature, if you think people on the community side of the thing or the customer side of things just are, or what are the list of the features are?
Oh, wow. Okay, that would be a hard one. Okay, but to your question, like features, there's a lot. I mean, last year, I think the major thing we released last year was 65,000 node support. So to give a little bit of context, Kubernetes upstream is tested for 5,000 nodes, right? So you can create a cluster up to 5,000 nodes. We have been supporting 15,000 nodes for a while. I think since 2019 or something, or 2020, we announced that we can do clusters of 15K nodes each, right? And we have a lot of customers doing 15,000 nodes. And last year, somewhere around December, we announced 65,000 node support. So that comes with a little bit of re-architecting. So when I say re-architecting, it says Kubernetes upstream. There is nothing different between 65,000 nodes and the regular 15,000 nodes cluster. It's the same APIs, same everything. It's just the underlying storage layer is different. So we don't use etcd. We replaced it with something called Spanner. And then we optimized a bunch of things to make 65,000 nodes possible. Also, it is only supporting a subset of the Kubernetes functionalities. So we disable on purpose certain functionalities just to make sure that the cluster remains stable at 65,000 nodes. And I'm actually working on a story as we're talking. I'm talking to our engineering team. I'm trying to do more like technical write-ups about how that's possible. How did we manage to make this a thing, right? So like make the information about how we achieve this scale public. So that's one of the things. Like it sounds ridiculous to say like 65,000 nodes to a lot of people. The reality is, from my experience, we will have probably 10 or 20 customers that will run at that scale. But for a lot of customers, that when you tell them we support 15, they will stick to 10 because they don't want to test the cluster at its like absolute maximum. So if you raise that bar a little bit, then you're allowing them to like go a little bit further. So instead of creating 2 clusters of 10K each, they can just do 1 cluster of 20,000 nodes, right? Things like that, right? So the other things, one feature that I really, really like, which is actually becoming now very important in the age of AI, is something called image streaming. So the image streaming feature is a feature that allows us to create inside our infrastructure a set of cache layers that allows us to cache the images and make the pull of the images toward the node faster. And this is very important for AI workloads because AI workloads containers tend to be very big. And so between the time you deploy a pod and the pod becomes ready, there is that time it takes for the node to download the image, right? So with image streaming, we're able to like speed up that download time. And we actually added some, like we enhanced it recently, so it's even faster. So for the first time your cluster download the nodes, an image, it might take the same amount of time it takes if image streaming was disabled. So it will take a few minutes, but then the subsequent pulls are faster, right? And so this is very important for auto scaling, because basically we pull the image the first time and then we cache it, and then the next time we need to pull it, it's faster because the image is already cached. So we can very quickly make it available either on the same node or on other nodes on the cluster, right? So this is one of them. The second one is a feature we released literally, I think, 2 weeks ago. Just to give a little bit of a context, auto scaling have always been a pain for Kubernetes, right? And when I say auto scaling, I mean infrastructure auto scaling, not pod auto scaling. So let's take a very simple scenario. Say like you run 5 pods of an application, right? So you have a cluster, it has a certain number of nodes, whatever that number of nodes is, and then you run a certain number of pods, 5, right? And then you suddenly need to auto scale very quickly, right? Whether you do that automatically or manually, so you either go and scale manually, or you have like a horizontal pod autoscaler that's basically monitor incoming traffic and then auto scales the pod depending on traffic. And let's say, for example, you go from 5 to like 100 pods, right? What's likely going to happen is all these pods cannot fit on the existing nodes. So the cluster autoscaler has to kick in and look at the pods that are waiting to be scheduled and then create new nodes for them, right? So auto-scaling the underlying infrastructure. And so that's a problem that have been around for a while. So Kubernetes upstream has something called the cluster autoscaler, which is the component that does auto-scaling for the actual nodes, right? And there are like alternatives, like AWS has something called Carpenter, which is very popular in the AWS world, but that only supports AWS API, it doesn't support our API. So what we did is we basically rewrote the entire autoscaling stack. And then we also did some internal optimizations inside our infrastructure. So we call this COCP, Container Optimized Compute Platform. It's already in our documentation. There is a video about it in YouTube, and we're publishing a blog post next week about it. So what is COCP? So COCP is multiple things. It's a complete rewrite of the autoscaling stack. It's a set of virtual machines that are available inside our infrastructure that we can either resize live. So we can take an existing VM and then we can make it bigger. We can just add more CPU and memory and resize it without restarting it. And then also a pool of warm virtual machines. So those are pool of virtual machines that are warm, that are maintained by the cluster. So they're not shared. They're maintained by each cluster. And so those virtual machines can basically be assigned and added to the cluster very quickly. So instead of waiting for the cluster autoscaler to kick in, for our case, it's called the GKE API, the Google Compute Engine API, to basically create virtual machines, wait for those virtual machines to boot up, join the cluster, and then we can schedule pods on them. We have a set of virtual machines that we can either resize or a set of warm virtual machines. And in the benchmarks we've done, we can basically achieve like a 7x speed in autoscaling. So we can go from, I take a deployment, I autoscale it to 100, and then it takes like 60 seconds for the pods to be ready. And we can go all the way down to like 20 seconds for the pods to be ready, right? Sometimes even less. So this is COCP. We just released it. It's actually very cool. So if you are on GKE Autopilot 1.32 as of today, it's already enabled by default, so you don't have to do anything. And then it's coming to standard mode as well at some point eventually. So that's another optimization that we are also working on very heavily. And then the last one I'm going to quickly talk about is this large initiative that is not only us, between Google, ByteDance, Red Hat. It's called LLMD. It's basically a large initiative. It's a big project which is meant to make support for AI workloads better on Kubernetes and on GKE and OpenShift and all the other platforms that these providers provide, right? So it's a very large project. It has its own standalone website. It's called LLMD. And so inside of it, there is like a lot of initiatives that we're working on.
Awesome. Wonderful. These are some very good news. I think one thing, COCP, I heard first time. I know LLMD has been in the very wonderful phase. It's had some wonderful collaboration going on as well. And I think these things, even we live in the platform engineering and DevOps enablement world. And now the AI is trying to making a shift into it. So developer is now using intent, like I need a cluster with, let's say, 3 node in it, or I want to create 10 pods with the Node.js application. But soon the application has been expanded quite extensively. And then you need to scale up these application. And there are some bigger challenges for the some of the regulatory setup of the way they turned up the auto scaling providers. It's been not actually been fit for what the enterprises need. So it's been good to hear about COCP, that is container optimize contain compute.
Compute platform.
Include the link in the description so people can check out as well, because I think it's a natural shift where everyone, if you try to talk to anyone working in a Kubernetes, if you ask them what are your three biggest challenges, one of them is auto scaling, and it's
Yes.
quite traditionally been, and that's why I think more and more of the initiative built into this kind of initiative as well. But that's very good info. I will include the link, and I will definitely want to hear what people have some challenges in the auto scaling and what feature they like in the GKE optimized for the auto scaling setup. What are the some things available in there as well? But Abdul, we're trying to shift the conversation to the newer domain. That is, we live in a CNCF landscape. There are a bunch of tooling, and I think there are so many tooling. I think 50% of the tooling in the CNCF landscape, I think, comes from the Google team. Even though they've not been a builder of them, but they have contribution heavily on these landscape tools in the CNCF. So if you have talked to the customers or any enterprises, what have you find the most kind of capabilities, or call it, what are the most active open source tool from the landscape in combination with the GKE?
Oh, that's a very good question. So from the landscape, like the things that we see people using the most with GKE are things like Argo for sure. So Argo CD is very, very popular, right? Both Argo CD and Argo workflow. So both the CD pipeline and the workflows, the data workflows pipeline, right? That's very popular. Another one would be Istio, obviously, because it came out of Google. The whole service mesh concept came out of Google. And we are using it super well. We have customers using it super extensively. We have a managed offering called CSM, a Cloud Service Mesh. And it comes in like two versions. I have to admit that I started working on Istio around like 2020. In its like standard typical architecture. So like control plane, data plane, envoy, Istio-D, all that stuff, right? And then now I started looking into the new, there is like this new thing called proxyless gRPC. So Istio, as you know, Istio has like a typical architecture, which is like you have a control plane, which is the Istio-D, right? And then you have the data plane, which is envoy. And envoy basically runs as a sidecar. So the sidecar talks to Istio-D and then implements all the features that you want, right? But if you actually run your cluster, if you write applications that are completely gRPC, so not HTTP, just gRPC, the gRPC libraries that Google releases, the open source ones, they already have service mesh capabilities. So you don't really need to run a sidecar. The library itself can do everything that the sidecar does without a sidecar, right? So all you need is an actual control plane. So you can do there's multiple options you can use this. You can actually run Istio-D, but run only the control plane, no data plane, so no invoice. And then you can configure your gRPC app to connect to the control plane of Istio. And because gRPC, the library, it understands the Istio API, it's able to basically get its configuration from Istio, right? So that's one way. On Google Cloud, we have this thing called Traffic Director. And so the typical setup that we see is people using Traffic Director, which is like a managed control plane, with gRPC applications on GKE. So the control plane sits outside of GKE, and it does all the service mesh features like MTLS, load balancing, circuit breaking, all that stuff. And then the application itself has just a library that can connect to the control plane and then download its configuration. And then you, as a user, you can just configure Traffic Director using an API to say, do blue-green deployment, and then it will do blue-green deployment. So we call this proxyless. So it's basically gRPC without a proxy. And so this is another one that we see like as an alternative to Istio, but Istio is still very, very popular. We have a lot of people using Istio. I spend a lot of time on Stack Overflow, and also there's this thing called the Google Cloud Community online, which is sort of a Stack Overflow where people ask questions, and I see people asking questions about Istio all the time. So there is this. There's like a lot of other things like Kubeflow is very popular. Jax is also very popular. There is this new framework in Python called Ray, which is also very popular. So these are all very, very popular third-party CNCF landscape tools, if you want, that people kind of... Kyverno, of course, like all the policy stuff, like Kyverno, Open Policy Agent, Gatekeeper, all that stuff. I think that's one thing that I would like to highlight here. I think what we're trying to do with GKE, at least this is my understanding, right? This is my kind of like the way I look at it, is we're trying to make GKE a universal platform. So the whole point is that we want to make it as useful to a lot of people as possible. So there are features that are introduced to make GKE better. So scales better, more secure, more isolated, blah, blah, blah. Better support for multi-tenancy. We can talk about fleet stuff if you want. And then the goal is to just make it possible for people to plug and play whatever tools they want, right? We do have some guidance or some architecture or some like best practices for the popular ones. So like Argo CD, if you look for Argo on GKE, you're going to find like tons of documentation about it. But those are just more for us to kind of support the community in running those popular open source frameworks on our platform, rather than having like an opinionated way of doing things, which is we say, oh, we think you should do it this way. Rather, our approach, or the approach I see from the product, is that we want to make the platform as useful as possible for as many use cases as possible.
Yes, absolutely, 100%. And I think like these are the natural fit. The Istio is one of the service mesh that came out of the Google team, and the service mesh is being explored quite heavily in the landscape of the CNCF. Bunch of other tooling exists for such of the purposes. We can use Kubernetes service mesh in contrast with the GitOps provider, the policy engine, or the supply chain security kind of a mechanism. But now we see in the cloud, even in the Azure, AWS, in the GKE, those solutions who are actually predicting will become an upstream is now ready-made available. Some cluster, you go into the cluster, there are some open source tool enabled by default. So if in GKE, anybody listening to us, they have some kind of opinionated approaches to use some of the capabilities from the landscape. So what are some of the GKE default available even in the autopilot mode?
Yeah, so as of now, one of the only like plugin, if you want, or like tool that is available, we call them add-ons, is Ray. So this Ray framework. So to explain to people what it is, Ray is a Python framework for doing AI and ML, right? And so you have a set of libraries that you can import into your Python code to do training, fine-tuning, reinforcement learning, serving, whatever you want, right? And then once you do that, you can run it on top of Ray itself. And Ray is basically a cluster-based system. It has the same concept of like a control plane and data plane. And so your array cluster could be either deployed on top of a set of virtual machines, or it could be deployed on top of Kubernetes itself. And so the integration between Ray and Kubernetes is an operator called KubeRay. Okay. And KubeRay was open sourced by Google. And so what we do right now is we have a plugin that allows you to basically, when you are creating a GKE cluster, Autopilot or standards, it doesn't matter, you can choose to add Ray. So you tick a button or you add a flag to the G-Cloud command line, and then we deploy Ray for you automatically. And then we maintain it, right? So this is just one of the only, as far as of now, the only like open source thing. I think that we're going probably in a direction where we'll be supporting more. But for now, it's only Ray. Obviously, the other open source thing would be Cilium, which is what Data Plane version 2 is based on, right? So if you are creating a GKE cluster, you have the option to choose the CNI to be what we call Data Plane version 2, which is Cilium based. In Autopilot, it's default, you cannot change it. But in standard mode, you have the option to choose. And that's just open source Cilium. So it's eBPF based.
Awesome, absolutely. So I think I would love to see in the near future, like some policy engines being ready-made available in some GKE cluster, because as of now is we're asking AI to spin up cluster, and I want some guardrails built inside of the cluster. So if something have been bad happen, policy enforcement kicks in, and we can ask AI to remediate based on that policy violation has been happening. So I'm hoping there are some news coming out in the near future.
We'll see. I mean, GKE is a massive product. Like we have like 100 plus product managers, like thousands of engineering teams. It's very hard to keep up with like what's going on everywhere. So, and we are like the team, developer advocacy team working on GKE is very small. So we try to stay up to touch to what's going on, but it's true that like the product is progressing at a very, very fast pace.
Yes, absolutely. That's a challenge of living in a world of cloud market in itself. Things are going in a rapid pace. You actually don't have good amount of time to sleep into it by having some news populating all the time as well. But
Yeah.
Abdul, I think you have your own experiences that you actually collected on the Kubernetes podcast. And I'm hoping there are some news you have to gather around GKE. So now it's your time to tell us, like, when you actually did some Kubernetes podcast, what you have been actively hearing on the guest to actually appearing on your show.
Oh yeah, so it's funny that like I just recorded the new podcast this morning just before talking to you. I mean, so what we try to do with the podcast is we try to keep it as much of a community focused as possible, right? And one of the things that we have been asked to do this year is we've been asked to. So this is the feedback that me and Kathleen received last year when we went to Salt Lake City, into KubeCon North America in Salt Lake City. We met a bunch of people, and there was this thing that kept coming, which is people asking us, can we do end user? We want more end user. So essentially, we want people to come on the show who work for companies who uses Kubernetes internally. Not necessarily, it could be GKE or it could be something else, right? And we try to do more of those. But like the latest I can remember is we talked to Ricardo from CERN. He's a very popular person. Everybody knows Ricardo who he is. His episode is probably one of the most popular. And Ricardo, so inside of CERN, they have their own Kubernetes cluster on-prem, but they also use Google Cloud and specifically GKE as a bursting mechanism. So when they run out of resources on-prem, they can burst into the cloud. And the way they do that is an open source project called Q, which is an open source project, again, that came out of Google and has collaborators from CERN and from other companies. So that was actually a very interesting, eye-opening episode to do, because it was very interesting to hear like all the use cases for Q and how people are, mixing GKE and on-prem in a way that they can either, burst, like as in like expand to the cloud. And then we heard a lot of other episodes, like people talk about, using exclusively GKE or using GKE as like a kind of like fallback mechanism, or having like some sort of multi-cloud strategy where they're using GKE and EKS and AKS, right? So we've heard a lot of stories in the podcast.
Absolutely. I will link the episode. I think many people who live in the Kubernetes, they know Kubernetes podcast. And I'm actually really worried if somebody doesn't know that the Kubernetes podcast exists. Sorry to say that, it's a shame on you, because it's been some wonderful stories. Like, it's been a very, very good engineering conversations. Sometime you heard from the end user or some of the people, like CERN is one of the episode. You listen to the people and just try to evaluate how you have been developing and using the solutions and how other are using it. So this give you some data analysis point or the checkpoints. Are you going in the study phase of your adoption, or you need to actually do some other transitioning into the picture as well? So there's not much, but Kubernetes podcast is your way to go as well. I think if people listening to us from the YouTube Cloud Native FM, they'll see the link in the description and see what we're actually talking about on the Kubernetes podcast. So just a final thoughts before I leave you. There's platform engineering stuff been happening and some AI stuff been happening. So
Yeah.
gathering both of the news in one quick sentences, and I think this need another whole story of the podcast. I will chase you again to tell us how the platform engineering been evolving inside the Google as well. But tell us about these two trends are in the making. Every time to go to the KubeCon conference, AI and the platform engineering in the way. So what you have been noticing inside the GK engineering thing on these two sides of the equations?
Yeah, a bunch of things. Very like if we talk on the product side of things, very quickly, there are like in my opinion, there are like two features that we have released that are basically directly answering the question of platform engineering. There is this whole fleet thing that we have, like you mentioned earlier. So fleets is a way for you to basically configure clusters in a fleet, and a fleet is basically just a group of Kubernetes cluster that you can configure to be the same. So you can group clusters in a fleet, and then you use an API to say, deploy this namespace, and the namespace will be created in all the clusters at the same time. Deploy this policy. The policy, it's basically a way for you to enforce high-level things outside of Kubernetes itself. So you use the Fleet API to group the clusters, and then you can use the Fleet API to configure all the clusters to be the same. So if you have like a policy engine that you need to deploy and a bunch of policies that need to be enforced across 10 clusters, instead of doing it in each cluster separately, you do them in a fleet. And then the second one is something that we also released last year. It's called MCO, Multi-Cluster Orchestrator, which is essentially a tool that allows you to, if you have it's a tool that generates recommendations for where you should execute the deployment. So you have a bunch of clusters across multiple regions, multiple zones, multiple configurations. You put them in you configure them with the multi-cluster orchestrator, and the multi-cluster orchestrator have visibility across all the clusters. It knows the availability of the resources, it knows the capacity, and then you tell multi-cluster orchestrator, I want to deploy this workload, and these are the requirements for the workload. And then multi-cluster orchestrator will calculate what we call a placement and return the recommendation. The recommendation is go deploy this in this particular cluster, right?
Yeah.
Because it has enough GPUs available, for example, right? That's just one example. So these are two of these. And by the way, when I was talking about this whole process of recommendation, this is typically done by a CI pipeline. So you don't do it manually. You get you configure it to be done by Argo CD, right? So these are kind of two features that are fundamentally answering some basic platform engineering problems, right? Allowing a platform team to build a platform on which developers can, do things. I don't think we are gonna be in the business of creating a portal, an IDP, an internal developer portal or something. I think we want to be able to support the main ones that exist, like Backstage and any other developer portal that exists, because we just want to make it kind of more useful. As I said, make the platform as useful as possible to a lot of people. But to your question about what's happening in the platform engineering team, it's a lot. I mean, it's very hard to keep up with. I think that the shift toward agentic AI and kind of agent-based development and all this AI stuff is actually kind of pushing all the people in the platform engineering team to rethink how they are doing a platform, right? How they're building internal platforms. How are they making these tools available? And I think one of the shifts I am seeing right now is that people who are in the platform space, they're noticing that they cannot be they have to be flexible. If you are building a platform that you are making available to developers, the platform has to be flexible. You cannot be rigid. You cannot be restricting what people can do. You can't be in a situation where people say, I want to deploy this. And then you go oh, well, wait, I have to see, we have to check, blah, 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 right? So you have to build something that is flexible, but that can also allows you to enforce all the requirements, all the policy requirements, the security requirements, the cost control requirements, all that stuff, right? So I think that this flexibility is going to be one of the main challenges as the AI technology is evolving very fast. A very simple example, let's say I am a platform engineer maintaining a platform for a team, a company of 10 teams, and suddenly there is a team coming that wants to deploy DeepSeek. And DeepSeek requires H200, H100 NVIDIA GPUs. I can't be in a situation where I say, oh, I don't have this configuration supported in my cluster. Wait, I have to see, have to check, blah, blah, blah. It takes this kind of conversation brings us back to the time when creating a virtual machine inside an enterprise takes 2 months, right? So you can't be in that kind of situation. You have to have some sort of flexibility. So I think that this is probably one of the main themes we're going to be seeing going forward.
Yes, absolutely. As you nailed it perfectly. I think the flexibility is one of the cornerstone of these conversation in the platform engineering world, because recently there's a new wave of infrastructure requirement eventually comes up. We never able even to talk about in the small companies. Now we need more GPU reference. It is required a new level of infrastructure design consideration compared to the CPU based optimization, and you need to have a very concrete debate on the table in order to win this battle. Other than that, winning a battle is required a lot of investment, and you might waste a lot of time and energy into it as well. But it's super excited to meet you, Abdul, and I'm looking forward to the episodes coming up in the Kubernetes podcast as well, and hope
Thank
to
you.
grab more information, more knowledge from this podcast because it's always been having some wonderful conversation that I really like about most. So thank you very much for joining us today. So steady gears of team unburdened of quiet cheers to GKE, which held the infrastructure flame and gave back time so we could build the game. Raise your mugs, let the cluster grow. 10 year behind us and many more in the future show. Thank you very much for listening to this conversation. Hope to meet you again in the near episode. Thank you very much, Abdul. Have a wonderful day, everyone. Bye bye.